Hello everyone. Now we will discuss one of the most important topic, that is racemization and racemic mixture. Now, what do you mean by a racemic mixture? A racemic mixture, it is nothing but a mixture of equimolar amount of two different enantiomers. That mixture is known as the racemic mixture. Now, enantiomer, we know that enantiomer are those molecules, are a pair of molecule having same molecular formula, but their mirror images do not superimpose over one another. Means, for example, this is the 2-butane molecule and this is the 2-butane molecule. Means both have the same molecule, both are the same molecule. But you observe in case of 2-butane molecule, it is described over here as a S2-butanol, and this molecule it is represented as RS2-butanol, because though both the two molecule they have the same molecular formula. If you observe in case of S2-butanol, it contains 1, 2, 3 and 4 number of carbon atom. In case of 2-butanol, that is R2-butanol, again it contains 4 number of carbon atom. Here S-butanol, it contains 1 oxygen atom, again it will contain 1 oxygen atom. Same number of hydrogen atom is present in S and R-butanol. Though they have the same number of atom, means they have the same molecular formula, but if we place this molecule before this molecule, if we place this molecule over here, then you will get that this molecule is the mirror image of this molecule. And when we superimpose this molecule over this molecule, then these two molecules they do not superimpose over one another, and hence they are enantiomer of each other. And we have discussed that enantiomer in depth in the previous video lecture. Now this is the S2-butanol, and when we place this 2S-butanol solution, pure S2-butanol solution in the beaker, and when we pass the plane polarized light through it, then that pure S2-butanol solution, it will rotate that plane polarized light in the left direction, or it may rotate in the right direction. So if we consider here, if it is rotated in the left direction, then same if we put this R2-butanol molecule, solution of R2-butanol in the beaker, and if we allow the plane polarized light to pass through it, then again it will rotate the plane polarized light in this direction. Means both the molecule they have the same molecular formula, but they rotate the plane polarized light in the different direction, and hence both the molecule they are different, they are enantiomer of each other, and they rotate the plane polarized light in the equal and opposite direction. They are optically active molecule. But if we take the 2-butanol, S2-butanol and R2-butanol in the equimolar amount in the beaker, and if we allow to pass the plane polarized light through the solution, then that solution will not reflect, will not deviate, will not change the plane polarized light direction. That plane polarized light will pass through the solution as it is, because this is the equimolar mixture of 2-butanol and this is the equimolar mixture of R-butanol, R and S-butanol. Both the molecule they are present in this solution in the equal amount. So one molecule, when the plane polarized light will pass through it, one molecule will reflect that molecule in one direction, another molecule, S molecule which is present in this solution, it will reflect in the left direction. R-S-butanol which is present in this solution, it will reflect in the right direction. So net rotation of the molecule will be 0. Means the net rotation of the light in this solution will be 0. Means when the plane polarized light will pass through the solution containing equimolar amount of these two enantiomer, then that plane polarized light will pass through the solution without any rotation. And this type of the solution where equimolar amount of enantiomer are present in the mixture, and when we pass the plane polarized light, that solution do not reflect, that solution do not rotate, deflect or deviate that plane polarized light in either of the direction, that is in the right direction or in the left direction, then that type of the solution is known as the racemic solution or racemic mixture. And this phenomenon, that the racemic mixture which do not rotate the plane polarized light in any direction, that property of that solution is known as the racemization. That property is known as the that solution is known as the racemization. Now the formation of these two, the combination of these two molecule the equimolar combination of these two molecule, equimolar combination of these two molecule make that solution optically inactive. So individually these two molecules they are optically active if you keep if you place the solution of this 2-butanol in the beaker, if you place 2-butanol in this beaker, solution of this 2-butanol in the beaker, and when we pass the plane polarized light through the solution, then both the solution will rotate the plane polarized light in the different direction. But when we place both the solution in equimolar amount in the beaker, and when we allow to pass the plane polarized light, then that plane polarized light do not deflect, do not rotate in any one of the direction. It pass through the solution as it is. So this type of the solution, it is known as the racemic mixture. So in the university examination, the term racemic mixture or racemization is asked for 2 marks. So racemic mixture, it is nothing but it is a mixture of equimolar quantity of 2 enantiomer and process of converting optically active. Now these are the 2 individual molecules having same molecular formula, and they are the enantiomer of each other, and the combination, the formation of this solution which is optically inactive, that process is known as the racemization. Means the formation of the combination of these 2 molecules, the combination or preparation of this solution of these 2 molecules of equimolar amount, it is known as the racemization. So in this video lecture we have discussed the phenomenon of racemization. Thank you very much.